To finish up this week, we are going to continue talking about how to graph degree 2 polynomials. However, I'm going to introduce you to a new way that we can write the equation of a quadratic. So what we've learned so far is standard form of the equation of a quadratic function or degree 2 polynomial function, whichever you want to call it. And standard form looks like y is equal to a times x squared plus bx plus c. So vertex form is just another way to write the equation. So instead of writing it in standard form, you can also write it in vertex form. And vertex form looks like y is equal to a times x minus h squared plus k. Y is equal to a times x minus h squared plus k. So the reason why this is called vertex form is because the vertex of the parabola is in this equation. So remember, if we think about a parabola, the vertex of the parabola would be this point right here, the lowest point. And remember, when we write that point, we're writing it in the form of hk, where h is the x value of the point and k is the y value of that point. So h and k are actually in the equation of vertex form. So in vertex form, you can easily tell what the vertex of the parabola is without even having to look at its graph. So the vertex are just the values of h, k. Now, one thing I need you to pay attention to is that the sign in front of the k is positive, and in the point, k is also positive. It's a positive k. But the sign in front of the h in the equation is negative. But in the point, it's positive. So the sign of h is always going to be the opposite when it's in the point and when it's in the equation, but the sign of k is always going to stay the same. And I don't know, honestly, if we're going to have time to talk about it anymore in Algebra 1, since we're kind of wrapping up the year right now, but you will talk more about why that's the case in Algebra 2. So for now in Algebra 1, I just want to introduce it to you. I want you to be familiar with that. And then in Algebra 2, either next year or the year after that, you'll kind of figure out why and dive deeper into that. So for now, I just need you to remember that standard form is y is equal to a times x minus h squared plus k. And the vertex is hk, whatever the value that's being subtracted from x is, and then what's being added here is your k. So if you look at example 1, we are going to graph this equation that's written in vertex form. So my equation says y is equal to 2 times x minus 3 squared plus 1. Well, this means that y is equal to a times x minus h squared plus k. All this means is that the h value is 3 and the k value is 1. That means that h is 3 and k is 1. So your vertex is going to be at the point 3, 1. Now, will this vertex be a maximum or a minimum? Will it be positively or negatively oriented? So the way that we can tell if this is a maximum or a minimum is the value of a. So if a is positive, your parabola will be concave up. It'll be facing upwards. If it's negative, it'll be downwards. So if, I'm going to make a little note of that for myself over here. If a is positive, your parabola is going to be face up. If a is negative, your parabola is going to be face down. So because a is positive, a here is a positive 2, I know that it's going to be facing up, which means it's positively oriented. And because it's facing up and positively oriented, that vertex is therefore a minimum. Then we're going to wait to figure out our x-intercept and our y-intercept in just a second. And then for our axis of symmetry, remember it's x equals whatever the value of h is. Well, what was h? We already know h is 3. Looking from vertex form, we found our vertex. H is the x value of the vertex. So x is equal to 3 will be our axis of symmetry. So let's talk about what this means for our graph. So in our graph, I'm just going to rewrite the equation. Y is equal to 2 times x minus 3 squared plus 1. So for our graph, we already know that the vertex is at 3, 1, which is right here. We also know that this parabola is going to be face up. So if it's face up, that means that, I'm going to use a highlighter just for an example. If it's face up and its vertex is above the x-axis, is this parabola actually going to hit the x-axis? No, it's not. So because of that, we actually know that we don't have any x-intercepts. Or I should say no real x-intercepts. Our x-intercepts are imaginary in this case. But we will have a y-intercept, and we can figure out what the y-intercept is. So the y-intercept always happens on the y-axis when x equals 0. X is 0 on the y-axis, no matter what the x value is. So if I plug in 0 for x, what do I get for y in this equation? So to find the y-intercept, we're just going to plug in 0 for x. So we're going to have y is equal to 2 times 0 minus 3 squared plus 1. So y is equal to 2 times negative 3 squared plus 1. Negative 3 squared is 9. 9 times 2 is 18. 18 plus 1 is 19. So our y-intercept actually isn't going to fit on our graph. It's going to be at 0 somewhere up here, 19. Then, because I know that my parabola is face up, it's going to go through a point up here on the y-axis somewhere. This is my vertex. I'm going to pick some x values to plug in. I'm going to pick 1 and 2. And then just to find some other points. And then I'm also going to plug in 4 and 5. Just so I can get an idea of where this parabola is and how I can graph it just a little more accurately. So we found our y-intercept at 0, 19. All right, so let's plug in 1, 2, 4, and 5. I am silly. I don't know why I wrote 4 and 5 right there. Should do 4 and 5. And we're not going to worry about any negative x values because anything we plug in is, you'll see in a minute. It'll make sense in just a second. Okay, so let's plug in 1. So y is equal to 2 times 1 minus 3 squared plus 1. Y is equal to 2 times negative 2 squared plus 1. Negative 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. So we're going to have 1, 9. So the point 1, 9. Plugging in 2, y is equal to 2 times 2 minus 3 squared plus 1. So y is equal to 2 times 2 minus 3 is negative 1. All right, so negative 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. So we're going to have 2, 3. Okay. So we have a good idea of what our parabola is going to do off to the left here. And instead of actually having to plug the 4 and the 5 in, we can actually do something else. So my tablet's not doing a good job of recognizing that's my hand. Okay, so let's actually draw in our axis of symmetry. So we figured out up here that our axis of symmetry is x equals 3. So at the x value of 3, we're just going to draw that vertical line. And that vertical line splits our parabola in half perfectly. So that means that each of these points can be reflected across that vertical line. So for example, this point here is just 1 away from the axis of symmetry. that I forgot to label. This is my axis of symmetry, x equals 3. So then that means on the right side, I can put a point exactly 1 away from the axis of symmetry as well. Then here at the y value of 9, we're 2 away. So then at 2 away, it's still with the y value of 9. I can put another point here. And then we know our parabola is going to keep going up in that direction. And we have a pretty good idea of what this parabola looks like. This is a decent graph, and that's all we have to do to get it graphed. So now, for example 2, I want you to do the same thing. Try this on your own. So reading this equation, compare it to vertex form, y equals a times x minus h squared plus k. See if you can identify the vertex and whether or not it's a maximum or minimum. See if you can find the y-intercept and the axis of symmetry. So while you do that, press pause and then press play when you're ready to check your work. Okay, so the value of h in this case is actually -1. Because if you plug in a -1 here, you're going to have x minus -1 squared, which simplifies to x plus 1 squared. So, and then the value of k, you would plug in a -3 to get -3 instead of +3. So your vertex is at -1, -3. Is this a maximum or a minimum? Well, what's our a value here? A is -1. So because a is negative, we know that this is going to be negatively oriented, which means our vertex is a maximum. And it's negatively oriented. All right. Then our axis of symmetry is x equals whatever the h value of our vertex was, so x equals -1. Let's go ahead and plot the vertex and then think about what this graph is going to look like. So if I put my vertex at -1, -3, down here, and this thing is going to face down, we know that because of that, is it ever actually going to hit the x-axis? And the answer is no. So we don't have any real x-intercepts. They're all imaginary. They're both imaginary. As for our y-intercept, well, we know every y-intercept has an x value of 0, so we can plug in 0 into the equation. And just to remind myself what that equation was, y equals negative times x plus 1 squared minus 3. We're going to plug in 0 for x. So y is equal to the negative of 0 plus 1 squared minus 3. So y is equal to 0 plus 1 is 1. So the negative of 1 squared minus 3. 1 squared is 1, but the negative of that would be -1. So y equals -1 minus 3. So y is -4. So our y-intercept is at 0, -4. So 0, -4. Then we also know that we have our axis of symmetry, we said, was at x equals -1. So why don't we go ahead and graph that real quick. So we're just doing a vertical line through the x value of -1. And remember, this axis of symmetry is splitting our graph into 2 equal halves. So if there's a point right here that is 1 away from the axis of symmetry on the right side, there's also a point over here that's 1 away on the left side. Then we need to plug in a couple more values. Let's do 2, and let's do 3. All right, so let's plug those into the equation. Y equals the negative of 2 plus 1 squared minus 3. So y is equal to the negative of 3 squared minus 3. Y is equal to 3 squared is 9. So we're taking the negative of that and subtracting 3. So we'd get negative 12. So at 2, we would have negative 12. Well, this point is 1, 2, 3 away from the axis of symmetry. So on the other side, 1, 2, 3 away. So we don't actually need to plug in this 3 because we have enough points here to give us a clear picture of what this parabola is doing, and we can go ahead and just draw on the parabola. And there we go. That's it for this week. Thank you guys for a good week. Thanks for tuning in and watching my videos. These lessons should help you in Algebra 2 next year, or Geometry, whichever one you're headed to next. And I hope you guys had a good week. I'll see you on Monday.